We're carrying on in section 5, or chapter 4.5 here. We're getting to the part where we have to do change of variables for definite integrals. What does this mean? Well, throughout the first part of this section, all we've been doing is use substitution, and every integral we've done is an indefinite integral, which means we are ending in a plus c type scenario. Well, the difference now when we're getting to change of variables is when we're doing this use substitution, now we have limits of integration, which means we have to change our limits so that they are in terms of u and not in terms of x. That's really the big difference here, and why it's called change of variables. We're still going to use substitution to do our integration, but now instead of integrating in terms of x, we have to change those limits of integration so that they are in terms of u. That's really the biggest difference. It's one more step in our problem that we have to do. So let's look at example 20. We have the integral from 0 to 1, now it's a definite integral, of x times the quantity of x squared plus 1 quantity cubed. Okay, so still we're making u the most complicated piece, which is the x squared plus 1. Our du has to be 2x dx, and then we have to replace that x dx, so we got to make sure that we're replacing with du divided by 2. Alright, so we have to divide both sides by 2 there, so du over 2 is our x dx. Now, we have to replace our upper limit and our lower limit. So we're going to take the value of our upper limit and our lower limit and substitute it into our u equation. So we chose u to be x squared plus 1. So I'm going to take my lower limit, which is 0, and substitute in to the x squared plus 1. So 0 squared plus 1 is 1. So our new lower limit when we're integrating in terms of u is 1. I'm going to take my upper limit, which is currently 1. That's in terms of x. I'm going to substitute it in for what we chose for u as well. So I'm going to substitute in where the x value is. So it's going to be 1 squared plus 1, which is 2. So our new upper limit when we're integrating in terms of 2 is u. When we're integrating in terms of u is going to be 2. So now instead of integrating from 0 to 1, which was in terms of x, we're going to integrate in terms of 1 to 2, which is in terms of u. So now when we rewrite that integral becomes 1 to 2 of u cubed du over 2. So we're doing the same u substitution before, but now that we have limits, we got to change those limits so they match in terms of u, not in terms of x. So we're going to factor out the 1/2 in front, and we're going to have the integral from 1 to 2 of u cubed du. So when we do that, we're going to have 1/2. The antiderivative is u to the 4th over 4, and now we're going to evaluate that in terms of u, which is 1 to 2. Alright, so substituting in our upper limit and our lower limit, so now we're stepping back a couple sections. We're actually taking f of b minus f of a. We're finding the net change or evaluating the integral now. Okay, it's going to be 1/2 times 2 to the 4th over 4 minus 1 to the 4th over 4. So that 2 and 1, those are our limits of integration in terms of u. So simplifying that down, it's going to be 1/2 times 16 to the 4th, or 16 over 4 minus 1/4. So we get 1/2 times 15/4, which equals 15/8. Okay, let's walk through another example here. Example 21. We have 1 to 5 of x over the square root of 2x minus 1. So same u substitution we've been doing. U is the most complicated piece, so u is going to be 2x minus 1, giving us du as 2 dx. Okay, now we have issues here all around. Alright, when we do this, this is similar to example 13, which I didn't go through because it was incorrect earlier. We have to change things a couple times here. So u is equal to 2x minus 1, du is equal to 2x dx. Alright, first scary thing is right, there's no x for us to replace. So we have to solve our u equation for x. I've done that over here on the side. So when we use u equals 2x minus 1, we're going to substitute that in and solve that for x. So we're going to add 1 to both sides and divide by 2. So x, in terms of u, is u plus 1 over 2. We're going to have to substitute that in for x. We're going to have to substitute du over 2 in for dx. And we're going to have to substitute our u in. So now we got to do 3 different substitutions here. This problem is fully loaded. Not only that, we have to find our new limits of integration. So we have to plug in 1 and 5 in for our x value into the u equation. So our first u is our lower limit. So we're going to plug in 2 times 1 minus 1. We get 1. Our new upper limit is 2 times 5 minus 1, which is 9. We substitute in our upper and lower limits of 1 and 5 in for x in our u equation that we chose u to be. That's where our 1 to 9 came from. So this one, when we rewrite this integral in terms of u, we write it as 1 to 9, those are the new limits we calculated, 1 over the square root of u, because we chose u up above to be 2x minus 1. Then we have to do times u plus 1 over 2. That replaces the x value that's up here on our integral. We didn't get that to cancel when we made a du. And then we have to write du over 2. That replaces dx. So I've kind of laid this all out here at the bottom of page 11 for you guys to take a look at when you're going through your notes. This entire integral here, where we've rewritten it, I've rewritten on the right hand side here. So we're going to, this 2 times 2 that are in the denominator, that's 4. So we're going to pull out a 1/4, and then we're going to have an integral from 1 to 9. I rewrote the 1 over u squared as u to the minus 1/2. Alright, and then that u plus 1 stays there, and we have du. So your best bet, let's keep that 1/4 out in front of the integrand. We're going to go from 1 to 9. We have, I'm going to distribute that u to the minus 1/2 to the u plus 1. So there's a positive 1 on that u there. Remember, when we distribute, same base, we add the exponents. So that ends up becoming u to the 1/2 plus u to the minus 1. That original u there had a positive 1, which was a 2 over 2. If we rewrite that, so negative 1 over 2 plus 2 over 2 gives us a positive 1 over 2. So that's where that u to the positive 1/2 comes from. And then u times 1, or u to the negative 1/2 times 1 is where the u to the minus 1/2 comes from. Okay? Now we just do the antiderivative of each one of those terms and evaluate them from 1 to 9. So we're going to have 1/4 times the antiderivative of u to the 1/2 is 2/3 u to the 3/2. We've done that countless times. The antiderivative of u to the minus 1/2 is plus 2u to the 1/2. We've done that multiple times as well. Since we're still in terms of u, we're going to evaluate that integral from 1 to 9. So when we do that, we get 1/4 times substituting in 9 for both of the u's here, we get 24. Substituting 1 in for both of the u's here, we get minus 2.66. So we roughly get 5.3. Okay, that one, very, very, very loaded. It's pretty much everything that we needed to do. We had to do u substitution. We had to use that u to solve for x because we had to replace x. We had to replace dx. And we had to find new limits of integration. So this problem, probably best example, if you understand exactly what we're doing in this problem, you've got it down pat. Okay. So next video, I'll go ahead and pick up this problem here. It's very similar to questions 7 and 8 on your homework. So we'll start the next video with example 22.